start with is writing down the given. So ED is perpendicular to EF, and that's given. Okay? So the first thing I think we should prove is that EF and ED form a 90-degree angle. Okay? After we do that, we're going to use some angle addition to prove 7 plus 8 equals the whole thing. And then from there, we're going to prove that they're complementary. Okay? Do you hear the proof plan I'm doing in my head? Okay, I'm going to do it again. The first thing I'm going to do is prove that perpendicular lines gives me a 90-degree angle. Then I'm going to prove that 7 plus 8 equal the whole thing. And then we're going to prove that they're complementary. Okay? So, I know that that's what I'm going to do. I want to say angle DEF equals 90 degrees. And we're going to say definition of perpendicular lines. Okay. Then we're going to say angle 7 plus angle 8 equals angle DEF by angle addition postulate. Then we're going to say angle 7 plus angle 8 equals 90 degrees. We're going to call this substitution. So I took out DEF and put in 90 degrees. And finally, I'm going to say angle 7 and angle 8 are complementary. By the definition of complementary angles. How do we feel about that? Okay? Yes, Nathan.
For the definition of perpendicular lines, could it be the right angle postulate or no?
Could it be the right angle postulate? No. We know the right angle postulate discussed how all right angles are equal to all right angles. But we want to prove that, we're only talking about one angle, and we want to prove that that makes a 90-degree angle. Those perpendicular lines make a 90-degree angle. Okay? So we're going to go down to example 2. So that's our proof, and I believe it is the only one we're going to do. So we're going to move on to example 2. Okay, we're going to plot these points and determine if the lines are perpendicular. We know if they're perpendicular if the slopes are opposite reciprocals, right? So we're going to plot 0, 1, and -1, -2. Okay, let's figure out the slope right over here. We go up 1, 2, 3 over 1. Okay, the next one is -3, 2, and 3, 0. So let's find its slope. We went over 1, 2, 3, 4, 5, 6, down 2. Okay, so we are 2 over 6, -2 over 6, which reduces to -1/3. So are these two lines perpendicular?
Yes.
Yes. So they are perpendicular. Upside down T means perpendicular. Yes, ma'am.
Did you get 3 over 1?
I just counted. I went up 3 over 1 to get from one dot to the other. So we're going to go -2, -1. That's A. And C is 4, 1. So I went up 1, 2, and then I go over 1, 2, 3, 4, 5, 6. So 2 over 6 reduces to 1/3. So what would my next line have to be for it to be perpendicular? What would the slope? What? -3. Okay, so I'm going to graph -2, 3.
Just like the
Yep, and 0, -2. That slope is undefined. Okay. Let's look at example 3.
Why is it undefined?
Because it's a straight line.
Oh,
Okay. Yes.
Why was it -2?
Because it's -2. Okay. So we're going to decide whether these lines are perpendicular. The best thing to do is put them in slope-intercept form. So I've got line A is 2x minus 3y equals -4. So I'm going to subtract 2x from both sides. And then I'm going to divide everything by a -3. So that's for line A. Yes, am I going too fast?
Yeah, I'm still on that second graph.
Okay. So we're looking at example 3. I subtracted 2x from both sides, and then I divided by 3. For line B, I subtract 3x from both sides, and I get 2y equals -3x plus 9. Divide by 2. Okay, is this the opposite reciprocal of this?
Yes.
Yes, we flipped it over, we changed it from negative to positive, so A is perpendicular to B. Okay, I'm going to skip B because it's the exact same thing. Okay, C, we're just using that y2 minus y1, so we go -5 minus 2 over -1 minus 3, and that would give us -7 over -4, or 7/4. So then I do the other one right here. I don't know how I got -5. That's a very good question. It's magic. I don't know. 5 minus 2 is 3 over -4. Better. Okay. Then we've got 6 minus 2 over 3 minus 0, which gives us 4 over 3. So these two are perpendicular.
That's just for.
Yeah, if you're given 2 points, you just find the slope, and if it's the opposite reciprocal, it's perpendicular. Yes?
For A, where did you get the fractions from?
Okay, so I subtracted 2x from both sides, and I divided everything by 3. So I subtracted 3 from both sides, divided everything by 2. That's how I got a fraction. Okay, let's go to example 4. Yes. Okay, for example 4, we want a line that's perpendicular to y equals 3/4 x minus 3. It goes through the point -3a. Okay, what would the slope have to be if it's perpendicular? We flip it over, and then we make it negative, so it'd be -4 over 3. Did you get how I did that? If it's perpendicular, you flip it over and you change the sign. Now I'm going to plug it into point slope form. This is my x1, this is my y1. Point slope form is y minus y1 equals m times x minus x1. Now I'm just going to plug those things in. Are we good?
Yeah.
Okay, so y minus 8 equals -4/3 times x minus x1. Okay, now I'm going to distribute the -4/3. And I get y minus 8 equals -4/3 x minus 4. Because 4 times 3 is 12, divided by 3 is 4. Now I'm going to add 8 to both sides. And so y equals -4/3 x plus 4. Do I need to do another one like that, or are we okay?
Can you be?
Do B? Okay. B, we've got 4x plus 8y equals 13. and we want it to pass through the line negative 2, 6. Do I know what the slope is for that problem?
No.
So I have to get it in what? Y equals, this was before. So I subtract 4x from both sides. 8y equals negative 4x plus 13. Then what? How do I get y by itself?
Divide by 8.
Divide by 8. The same, 4 over 8 is the same thing as 1 over 2. And we'll just leave it as 13/8 because we don't care. So what is the opposite reciprocal of
2.
just 2? So we have x1, y1, and we say y minus y1, which is 6, equals the slope times x minus x1, which is negative 2. 2 negatives make a,
Positive.
we distribute. So we get y minus 6 equals 2x plus 4. Add 6 to both sides. Y equals 2x plus 10. Okay? Alright. Ready to turn it?
That was C.
That was B. Yeah. Ready to turn? Okay. Alright. We've got 311, which says perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, then it must be perpendicular to the other. So if J is perpendicular to H and H is parallel to K, J must be perpendicular to K. Alright, it looks like an I, sorry. Alright, if a plane of two lines are perpendicular to the same line, in a plane if two lines are perpendicular to the same line, then they must be parallel to each other. So if M is perpendicular to P and N is perpendicular to P, then M and N must be parallel to each other.
How would you find out?
So we're going to look at one like that. So let's flip it over. We're looking at example 1. Determine which lines, if any, must be parallel in the diagram. Explain your answer. Okay, so S is perpendicular to P, and S is also perpendicular to Q. Therefore, P must be parallel to Q. Do you see how S is perpendicular to both of these? Therefore, those two lines must be parallel to each other. All right, what else? We've got Q is perpendicular to S and T. Therefore,
S is S and T.
S is parallel to T.
Is that it? Wait, hold on. How is Q? Oh, perpendicular.
Okay. Example 2. From this picture, is A parallel to B and Y?
Yes.
Why?
Perpendicular.
Because D is perpendicular to both of them. A is parallel to C because A is parallel to B, thank you. C would not make any sense. A is parallel to B by Theorem 312, lines perpendicular to transversal. Okay, what else do we got? Is B perpendicular to C?
What is it? Line perpendicular?
Is B perpendicular to C? If we know that A is parallel to B,
Yeah.
okay, since A is parallel to B,
311.
and, yes, and A is perpendicular to C, B must be perpendicular to C by, what do we call it?
Perpendicular transversal.
Perpendicular transversal theorem.
What does it say? B is perpendicular to C by
Perpendicular transversal theorem.